it going, everybody, in your quarantines, homes? Hope we're all living our best lives in quarantine, trying to stay away from as many people as you can. We're going to do some geometry, go over some parallelogram practice, some quadrilateral practice. And before I even get into this lesson, I want to try to go through all the definitions first, and then we'll kind of come back and answer some of these questions up here so that we don't get too lost trying to figure them out. So again, just follow along, cimath.com. You'll find all of the worksheets that we're doing here. So this shape is going to be new for some of us. This is a trapezoid. Okay, again, they're all going to fall under the quadrilateral family. Hi, Jose. We're all going to fall under our quadrilateral family, and so we'll kind of look at some of the different rules that go along with them. Oh, you're welcome, Tiffany. So here we go. So this is a trapezoid. So now what we want to understand about a trapezoid is they have similar names, right? So the top and the bottom, those are going to be called both base. Sometimes I'll label it as base 1 and base 2. And then your two over here, these guys are going to be called the legs. Okay, so they don't have like a top and a bottom. They just call them base 1 and base 2. So then when we start to write our rules over here, you'll kind of understand what I'm talking about. So when you have a trapezoid, one of the properties is one set of opposite sides are parallel. Okay, so if you would look at this one, you could see that the bases are going to be parallel. Okay, so that's one of them. And then since, if you kind of remember our rules for parallel lines cut by a transversal, the consecutive sides, those sides that are next to each other, add up to equal 180. Okay, and then if I just drew a second transversal, look how it just created the trapezoid. So that's where that rule comes from. So you'd write consecutive angles equal 180. Okay, so it could be over here and over there, or over there. Now I'm going to kind of break this part up for 3 and 4, and we're going to call that an isosceles triangle. Okay, an isosceles triangle, trapezoid. An isosceles trapezoid. And it's going to be very similar to what I was saying on the isosceles triangle. So you guys know that if you have a triangle and we call it isosceles, two sides would be congruent. And in the case of the isosceles trapezoid, the two legs are what would be considered congruent. And then what we also know about is that the base angles, or those angles opposite those congruent sides, would also be congruent, and that's exactly what's going to happen for the trapezoid here. So opposite of the legs, the base angles, whichever they are going to be congruent, and then the same thing can be said about those upper angles as well. They can be considered congruent as well. So we'll say legs are congruent, base angles are congruent as well. And then we just explained that before. So you can always go back, you can always look, pause the video, go back later and get the rest of your definitions there. And now some of our more familiar shapes, and we have the parallelogram. So the first one is we would say that opposite sides are congruent. Now, also with that, opposite sides are going to be parallel. So here I can write and parallel. Then we can talk about the diagonals. I drew diagonal AC and diagonal BD. They bisect each other. So if I called this intersection point E, AE would be congruent to EC. DE would be congruent to BE. So we write diagonals bisect. Okay, and then we can now erase this to clean it up a little bit, and we'll talk about the angles. And then again, very similar to the trapezoid, because we have parallel lines here, we can say these consecutive sides, A and D, they're not the same, but they can add up and equal 180 degrees. Okay? Consecutive sides equal 180 degrees. Okay, there's some. Now, I'm not just talking about A and D. I could talk about A with B, or B with C, or C with D. Remember, consecutive means next to each other. So A is next to D, A is next to B, and so on. And then the last one is opposite angles are congruent. So angle D is congruent to angle B, and angle A is congruent to angle C. So there are your rules for a parallelogram. Then we move down the chain and we go to a rectangle. A rectangle is going to share all of the exact same properties as the parallelogram, but then we're going to add a couple more. And that now here I know that for the rectangle that all of these angles here are going to be the sides are perpendicular, so the angles are going to be 90. So each angle equals 90 degrees. That's one. And then if I drew diagonals AC and BD, yes, it's true that these diagonals bisect, but the diagonals now are also congruent. Okay, so again, they're going to share these rules, and then we're going to add these rules to them. Okay, now we move on to the rhombus. So the rhombus is not going to share rectangle rules, but he's going to share the parallelogram rules, right? Okay, so these guys can share, but these guys don't. Now the difference here is, and you can see why they don't share, because these angles are not 90 anymore, but all of the sides are congruent. So all sides are congruent. And then again, if I drew diagonals here, while it's true the diagonals do bisect each other, but now this is probably the most important rule that you're going to have or you're going to see all the time, is these diagonals are perpendicular. Diagonals are perpendicular. Now a little hint for you, what they like to do, or what questions like to do, is for the rhombus, they like to talk about the sides. Keep in mind, because we now have a right triangle, they like to use the Pythagorean theorem of a squared plus b squared equals c squared, and c is going to be the side of the rhombus. Okay, keep that guy in mind there. And finally, the square, and the square just literally has everyone's rules. The square, all sides are congruent. The diagonals bisect. The diagonals are also congruent. The diagonals are 90. Sides are parallel. So literally for this one, it's okay, you just literally have everyone's rules. So that's this, and again, as much as you can, memorize these rules. You have to know that. There's a good little family tree that we like to have for this, for the quadrilaterals. And then this will help us answer those first questions. So for quadrilaterals, okay, you can have the parallelogram. And then we have what we just learned, which is the trapezoid. And we're going to move down the tree. And as we move down the tree, the purpose of having this is it's just going to say all the rules go down to that person. So the trapezoid, all of the rules of the trapezoid can then go to the isosceles trapezoid. Okay, all of the rules from here trickle down to this guy. Now in the parallelogram, all of the rules for the parallelogram can filter down to the rectangle. All of the rules for the parallelogram can filter down to the rhombus. Then all of these rules here can filter down and into the square. Now the purpose of it is for those questions like we have, which we're going to ask you true or false. So you can now talk about who can be what. So let's look at an easy one. Say a rectangle and the parallelogram. The obvious difference, if you're just looking at them, is the rectangle has a 90-degree angle and the parallelogram, they do not. So one of the things they like to say is, can this guy be that guy? Well, think about it. The rectangle has all of the rules of the parallelogram, right? The rectangle has all of the rules of the parallelogram. The parallelogram does not have all of the rules of the rectangle, i.e. the 90 degrees. So when you go and do these questions in the front here, basically you're looking at that chart and saying, okay, can you move up the chart? If you can move up the chart, you're true, and if you're moving down the chart, you're false. And you can't go left to right. So if I'm going to draw that quick just by shape, okay, you have your trapezoid, then you have your isosceles trapezoid, then you have your parallelogram, then your rectangle, your rhombus, and then here's your square. So the first one, all rhombuses are rectangles. Here's the rhombus, here's the rectangle. Well, they're next to each other, so that one's going to be false. All rectangles are parallelograms. All of the rectangles are parallelograms. So again, if you can move up this tree, you're true, because the rectangle got all of his rules from the parallelogram. So you're going to say true here. All trapezoids are parallelogram. Here's your trapezoid. Okay, you're moving over, not up, so you're gonna be false there. All rectangles are squares, so the rectangles are the squares. Well, can a rectangle have all equal sides? So that's why you're going to say false. And then again, you're moving down the tree. All parallelograms are trapezoids. So here's the parallelogram and here's your trapezoid. So you're false there. All rhombuses are parallelogram. Here's your rhombus. Here's your parallelogram. True. All squares are rectangle. Here's your square. Here's your rectangle. And all rhombuses are square. Rhombus is square moving down. False. So there you go. So there's kind of your true-false questions. So again, go back, make sure you have these rules memorized as best you can, because it'll help you when you're doing proofs or when we're going to do these questions we're doing now, because if you don't know your rules, you won't be able to answer them. So first one is isosceles trapezoid. DE is parallel to GF, so those are my bases, and since it was isosceles, I know this guy is going to be congruent to this guy. So now it says DE is equal to 4x minus 2. It said EF is 3x plus 2. So here's EF, that's 3x plus 2. FG is 5x minus 3. And GD is 2x plus 5. Find the value of x. So they gave me all sides, but the only sides that could be important to us or are going to be important to us are the sides that they told me are going to be equal to each other. So 2x plus 5 is equal to 3x plus 2. Now you solve for x, subtract 2x, subtract minus 2, so x is equal to 3. And then they could give you this question and ask you to find DE or GF. Okay, so they might not even tell you to find x, but this is the way you would find any one of the sides. You would set your two congruent sides equal to each other. Okay, 2. Okay, and again, isosceles trapezoid, so AB is parallel to CD, and then they tell me that AD is going to be congruent to BC. Now they're talking about angles, so the measure of angle BAD. So go take your time, trace angle BAD, and that center angle, that's where you are, and rewrite all angles inside. So there's 2x. And then BCD is 3x plus 5. So here's 3x plus 5. So now, again, we're opposite of each other. So we know that opposite angles are going to be equal to 180 degrees. Okay. Do some math. 2x plus 3x is 5x. 5 plus 5 is 10, equals to 180. Move the 10 to the other side. So that's going to be 5x plus 10 is equal to 170. Divide both sides by 5. And that's going to be 35. Okay, so now, if you stop there, you're not going to have your full answer because they didn't ask you to find x. Okay, they asked me to find the measure of BAD, which is right here. So that now I have to do 2 times 35 and write 70. So the answer is going to be 70. So just be careful. Okay, now let's do some questions where they're not going to give me the picture. Okay, it's my job. Now you have to be careful when drawing your pictures. They don't care where you put A, B, C, D, but they care how you write down or put A, B, C, D onto your picture. So you could start anywhere you want. Just know wherever you start, just move in either a counter or a clockwise location. Okay, so if I start the A here, I'm not going across for B. I can either put B, C, D, or I can go this way and put B, C, D. Just don't jump the letters across from one another. Again, now talking about angles, angles are inside. So here is the 2x plus 50. Angle C, that's 3x plus 40. Opposite, parallelogram, opposite angles. So I'm going to do 2x plus 50 plus 3x plus 40 equals 180. Okay. Again, do your math. 2 plus 3 is 5. 50 plus 40 is 90. Equals 180. Subtract 90 on both sides. So 5x is going to be equal to 90. Divide both sides by 5, and x is equal to 18. So, but again, be careful. They didn't ask me to find x. They asked me to find a. So what are we going to do? You're going to go ahead and substitute that right into angle A. So I'm going to go angle A. They told me is 2x plus 50. So I'm going to do 2 times 18 plus 50. And that's going to be 86. Yep, 86. So my final answer is going to be 86 degrees. Okay. 4. Find the length of the side of a rhombus whose diagonals measure 12 and 16. So watch how I'm going to go ahead and do this picture. So here's my rhombus. They're talking about diagonals. So here's a diagonal right there. There are 2 of them, so I'll draw both of them. Now you have to know the rules of diagonals. They bisected each other. So it doesn't matter where. If they're telling me that one of the entire things is 12, just to keep my picture a little bit neater, I'm not going to write 12. I'll just bisect it and write 6 and 6. So I'll put a 6 here and a 6 there, because 6 and 6 make 12. And I'll do the same thing for 16. I'll put an 8 here and an 8 there. Now what they asked me to do is they asked me to find the length. So the length doesn't, or the length of one of the sides. Now we know a rhombus, they're all the same, so let's just put the x here. I gave you that tip before. A good thing to keep in mind when they're talking about diagonals and sides is this guy is 90. So if I just isolate this little part here, look at what we're looking at. We're looking at a right triangle where the 2 sides were 6 and 8. And then this, which is the side of the rhombus, is going to be the x. And then we're just going to do a squared plus b squared equals c squared. A and the b don't matter. Just remember the hypotenuse is always opposite of the 90 degrees. 36 plus 64 is x squared. 36 plus 64 is 100. And take the square root. So one side or all sides of the rhombus are going to be 10. Okay, 5. The lengths of the diagonals of a rectangle. So now we're talking about our rectangle rules. And what I know about these diagonals is that they are congruent. Are represented by 2x plus 3 and 4x minus 11. So the entire thing is 2x plus 3. The entire thing is 2x minus 11. It does not matter. Diagonals are congruent. So 2x plus 3 equals 4x minus 11. And then we just do some math. Subtract 2. 4 minus 2 is 2. Add 11. That's going to be 11. 3 plus 11 is 14. Divide by 2. They said to find the value of x, so now I'm done. Okay, 2 more left to go. 6, the diagonals of a rectangle ABCD intersect at E. Okay, so I'm going to do this over here. It's just going to give me a lot more space. Now, it's best to draw a picture. Doesn't matter where you start with the A, just make sure you follow in the right order. Then you have the diagonals, and they said that they intersect at E. And now they said DE is 3x plus 1. So I'm going to do 3x plus 1 here. AC is 5x plus 4. Now, I'm going to have to be a little bit careful here. I'm going to write that here, 5x plus 4, nice and big note so that I know it's actually the whole thing. Diagonals bisect, so if he's 3x plus 1, then guess what? The other side can be the same thing, 3x plus 1. So really, I could take now the 2 little sides and create one big side by adding them up. So 3x plus 1 and 3x plus 1 would make the whole entire diagonal of DB. And then that would be the same as the entire diagonal of 5x plus 4. Now let's just go ahead and do the math. Simplify on the left, so that's 6x plus 2 equals 5x plus 4. I'll move the 5x over here. That's 1x. I'll subtract 2 over here. So the value of x is 2. Okay, and I'm done because that's all they asked me to find was the x. And last one. So now we're talking about a rectangle also, but now we're going to be doing our angles. All right, so angle 1 is 42. So if it's an angle, I got to write it inside. So here we go. 42 goes right there. And it says, what is the measure of angle 2? So that's x. In order to be able to do this properly, you have to be careful because you have to, again, remember your rules for parallel lines. Okay, this is called alternate interior. So that means that this guy right here, he can be 42. Okay, so whatever this guy is, then that guy is. What you could also try to remember, again, because it's a rectangle, since the diagonal is bisected, really what you created right there was an isosceles triangle. Since both of the diagonals are the same, and the rule from parallelograms, they bisect, that means this is what you're looking at. So x can go here, 42 can go here, 42 can go there. 1, 2, 3 angles of a triangle. How many degrees do they equal? Okay, and that's going to be 2, 180. And x plus 84 equals 180. Move the 84 to the other side, and you're going to get 96. And x is what I made angle 2. So there's your answer. Okay, so that goes over all of our quadrilateral rules. So one of the things that I want you to do is I want you to go on www.cimath.com. On there, under Unit 9, there's going to be like a quiz, practice, call it what you will, but just something that, so Miss Holden and I can see that you are maybe trying the work, doing the work, what do you understand, what don't you understand, and this way we can gauge how well that these videos are doing for you. So go ahead, give that Google form a try under Unit 9 in the Geometry tab, and we'll give you about a week to try to get that done. And we will be back live again on Monday. Have a safe and quarantined weekend.